Thank you for watching our Day 2 recap of RI3D at Iowa State University.
I'm Austin Knutson, and I'm the manufacturing lead.
And I'm Becky Murphy. I'm a part of our manufacturing subsystems.
At the end of day 1, our design team worked overnight to finish the CAD model and produce blueprints for us to manufacture with. A part of our design process was determining what material we should make our parts out of. We were voting against either aluminum or plywood. Ultimately, we decided on aluminum due to the increased strength, rigidity, and increased professionalism from the aesthetics. A big bonus of using aluminum is that we can produce these parts on our CNC mill using conversational programming. However, for those who don't have access to a CNC conversational mill, this also works on traditional G-code, or if you're talented enough, you can do this by hand. Unfortunately, when we chose aluminum, we ended up running into a few problems when trying to mill them. It consisted of a steep learning curve, difficult setups, and long part cycles. Because of all these problems, it increased our turnout time to over double, which ended up being roughly 12 hours from start to finish.
While our manufacturing team was creating these parts, we were assembling our drive base by attaching our climber, removing our electronics, and adding a versaplanetary off of our custom gearboxes. The versaplanetaries encountered some issues as none of us have been familiar with them for a while. Shout out to Team Neutrino mentor Jamie Preston for helping us get through these problems. While our climber was being assembled, we were also printing hardware such as gears, spacers, and hubs for pulleys. And we were troubleshooting some of our issues with space claims, and we found out our gears melt when they are drilled. During this time, we were also assembling our bumpers and making those legal for the third time now, but we have done it. Later in the afternoon, we also assembled our shooter, which we are currently testing as we speak.
As we began working into the night, we took measurements for our hopper and we took them back to my apartment to get them cut on my table. Once we were done making the parts, we brought them back to our workspace where we began the final assembly for the floorboard of our hopper.
While we were cutting pieces for the hopper, we also had people working on the intake. When they were working on the intake, they discovered that our gearing was wrong, and so we were troubleshooting solutions, and we are currently in the process of finding one that's going to work.
Our team continued to work throughout the night, and during final testing, we ran into a big problem with our wiring. Unfortunately, there was a simple overlook where we accidentally crossed wires on our VRM, causing it to short out and burn the VRM. On the positive end, we are still able to manually test all of our motors without actually driving the robot around. Because of this, we were able to confirm that the majority of our code works, and we were able to get our Steam Deck operational as a secondary controller.
Once the bot was passed back to mechanical after wiring was completed, we attached the shooter and mounted everything for final testing. We are currently in that process as we speak.
Lastly, we're happy to announce that our robot name is Indy.
Hi, my name is Ella Meyer, and I'm president and co-founder of Robot in 3 Days at Iowa State University. Thank you for watching our Day 2 recap. Today we spent the day building the first version of our robot, and we can't wait to show you the final version tomorrow for Day 3. Today for Day 2, I would like to thank our sponsors: Iowa State Student Government, Master Tool in Manufacturing, Milwaukee Tools, John Haskell, and we would like to thank our partner FRC Team 3928 Team Neutrino for loaning and donating parts as well as assisting us in building the field elements. Thank you. This event would not be possible without you. See you tomorrow for Day 3.